Welcome to myprojectbazaar.com. Here we are going to discuss about pilot design for Sparse channel estimation in OFDM-based CR systems. Channel estimation technique, which is most important in the design of OFDM-based cognitive radio systems. Cognitive radio systems which are most applicable in audio-video transmission purpose. So a novel scheme of pilot design based estimation of sparse channel is proposed in this paper. An updating rule for probability of selected subcarriers derived, and also the energy efficiency and capacity for the system also done using energy efficiency optimization algorithm. The sparse channel estimation introduced in OFDM based CR system is the first step. Based on the results of spectrum sensing, the pilot design is studied. In this model, an optimized pilot pattern is obtained using cross entropy algorithm. The cross entropy algorithm based on several constraints. Hence it is called a constrained cross entropy optimization, which is modeled as independent Bernoulli random process. So a projection method is also proposed, and the number of pilots should be varied. For 64 and 75, the channel estimation performance is evaluated using least square estimation technique. So the comparative analysis also made for 64 pilots and 75 pilots. The energy efficiency and capacity also calculated using energy efficiency optimization algorithm. Here the spectrum efficiency, which is 11.5% improvement, is also achieved. Next, the system architecture of our proposed system. It consists of 5 major blocks: OFDM, channel estimation, cross entropy algorithm, energy efficiency optimization algorithm, channel performance evaluation. OFDM, it is the base architecture of any multi-input, multi-output system. Our OFDM consists of random generation of any number sequences, and this sequences is to be transformed with Fourier transform technique, and the pilot insertion in this symbols we get pilot pattern. That pilot pattern is sent through the channel. Next process, channel estimation. Here the channel estimations are declared by using channel coefficients. The channel coefficients and the initialization parameters for cross entropy algorithm, they are all performed here. Here the number of symbols and the number of pilots and length of the duration and time allocation, random number of samples and step size, they are all declared in the channel estimation technique. And cross entropy algorithm, this is the most important algorithm to get optimized pilot pattern sequence. In this, the inputs are number of symbols, pilots, and the length of application. First step is to generate the G matrix, which is random generation matrix, and in the second step the J random samples from the generation of matrix G, and the restriction condition for the projection based method obtained here, and obtain the objective values from this condition. Finally checks the new samples and old samples. The variation of new samples and old samples are declared using cross entropy algorithm. And fourth method, that is energy efficiency optimization algorithm. Here the energy efficiency and capacity of the system is evaluated. The message signal and the number of pilot symbol associated with the message signal are randomly given to this algorithm. This algorithm gives the energy efficiency of the system and capacity of the system for various number of transmitters, receivers. Depending upon the transmitters and receiver, it checks the value of random signal and error performance capacity analysis. Finally, channel performance. This block comparatively analyzes the error rate performance and energy efficiency and capacity of different pilot numbers, that is 65 and 70, 64 and 75. Next we are going to discuss about the running procedure of our proposed system. This procedure consists of 6 major functions. One is main function and associated functions are the subfunctions. The subfunctions calculates the error performance and energy efficiency capacity system. Pilot 64 subfunction which calculates the error estimation performance of 64 number of pilots, and pilot 75, this calculates the error performance of 75 number of pilots. In both 64 and 75, the crash entropy parameters are declared in generation of MCE and the score factor of MCE is calculated here. And finally, the error estimation performance are also done in pilot 75 and 64 calculation. The main function, it consists of the declaration parameters for energy efficiency capacity algorithm initialization parameters. The requirement of pilot design based scheme that consists of the number of samples m and the number of pilots k, l, that is the length of the interval, they are also displayed here. The initial calculation parameter, that is q, that is random number of samples for j, which is declared here. The probability function are estimated and the restriction conditions checked. If the condition is satisfied, then the correlated samples taken from this window. Finally, the output of the window, that is q of t and q of t plus 1, the after samples, before samples, they are also evaluated in this performance. The initialization parameter of energy efficiency optimization algorithm are declared from this main function, which is called to the subfunction. The energy efficiency optimization algorithm, this receives number of transmitter, receiver and the simulation value and bandwidth value, temperature factor and angle. Using the singular value decomposition method, so subchannel gains are arranged in ascending order. The optimized transmission power allocation threshold calculated from this window. According to the power constraint, we can estimate the error performance, capacitive evaluation, energy efficiency of the system separately. The optimum capacity is calculated from this algorithm. The running procedure consists of several steps, that is pilot 64 error estimation, pilot 75 estimation. In this matrix representation, the bit error rate analysis of 64 is displayed here. Finally, the error estimation performance, capacitive analysis, they are all displayed in this window. The bit error rate 2 estimation, it is for 75 number of pilots. Now I explain each figures. Figure 1. This shows the error rate performance for 64 number of pilots and 75 number of pilots for various signal to noise ratio in decibel values. And in figure 2, this shows the energy efficiency of the system when the number of transmitter receiver are varied 1 through 4. For various power constraint, the energy efficiency graph is plotted here. And finally, the capacity graph, this shows the variation of average power constraint with the capacity for the number of transmitters receiver varied from 1 to 4. Thank you.